Welcome back. Today we're going to be talking about solving one-step equations. Specifically today, we are going to be focusing on decimals and fractions. Our content objective is students will be able to solve one-step equations. Language objective is students will be able to clearly state their reasoning with regards to finding the solution. And why am I learning this? Well, it's important for science problem involving force, acting on an object, possibly finding distance, rate, or time, things like that. So background knowledge, we do need to remember what an inverse property is and what it does for us. So the word inverse basically means opposite or reverse, okay? So in this case, we've learned about the inverse property of addition, and what you're going to find with that is this property allows us to create zero, which is going to be very helpful for us in solving equations, and you'll see that. We're also going to be utilizing the inverse property of multiplication. This is also something we're going to be utilizing a lot to create the number 1. So why are we trying to create 1 and why are we trying to create 0? Because in certain cases, adding 0 is not going to affect the equation or expression, or in a different case, multiplying a number by 1 won't change it either. So these are two very important properties that we will be using to solve equations. So let's also remember what are the inverse operations. Addition and subtraction are inverse operations, and multiplication and division are also inverse operations. Basically, these inverse operations undo one another. Another very important thing to remember is the different types of properties of equality. These 4 different property of equalities allow us to keep our equation balanced. And you've heard it plenty of times before in math. Whatever you do to one side, you do to the other. Because we don't want to change the equation. We want to manipulate it so we can figure out what the value of the missing variable is, but we don't want to, again, change the value. So we always want to make sure whatever we do to one side, we do to the other to keep it balanced. So in 6th grade, you first learn how to solve one-step equations, and your solutions were always positive. In fact, sometimes they were the type of problems you can do in your head, like x plus 5 is 14, 6w equals 42, w over 4 equals 11, okay? So what's so different about now and 7th and 8th grade? Well, in 7th and 8th grade, you're going to be working with some values that you can't always just do in your head. That might be one-step equations involving fractions, or one involving decimals, or possibly both. And in fact, it will only get more complex as we move along. We'll move from 1 step to 2 steps to multi-steps, and even to having variables on both sides. So it's important that we learn to show our works. To show our work, not works. Okay? And in fact, you're going to find that if you don't show your work, you're not going to get credit. So please make sure you show your work. Okay, so with that said, let's take a look at a problem here. So this is pretty complex. Is this the type of problem you can do in your head? I mean, it's great if you can, but in most cases, including myself, I wouldn't be able to do this in my head, so I would be expected to show my work. So here is the answer. Our answer would have been negative 21 and 7/17. So the point of this problem is to, again, remind you it is so important for you to show your work, show your steps, because things are going to get more complex from now on. Right now, technically, we only are working with 1 step, but again, the complexity is going to increase as we move along. So with that said, let's remind ourselves what the rules for transforming equations are, and then we can go ahead and jump into some examples. So number 1, our main goal is to always get the variable on one side of the equation by itself. You're often going to hear me say to isolate your variable. Number 2, always perform the same operation to both sides of the equation. This is going to allow the equation to remain balanced, and that means you're not changing the equation at all. You're just manipulating it to make it serve your purpose. Next, to undo an operation, perform its inverse operation to both sides. The inverse, again, will either create a 0 or create a 1, which is going to be very helpful for us because, again, adding 0 to a number is not going to change it, or multiplying a number by 1 won't change it either. So remember, addition and subtraction are inverses, multiplication and division are inverses. And last but not least, please make sure you always show all of your steps. So here we go. Number 1, we have n minus 3.5 equals negative 4/5. I personally find it helpful to kind of read the equation out loud. Why? Because by reading it out loud, I'm able to sometimes determine the operation so that I could figure out the inverse, because that's what's going to allow us to create either a 0 or a 1. So we're either using the multiplicative inverse to create 1, or using the additive inverse to create 0. So now the first thing that I highly suggest most of you do is to identify our variable. Here we have n. Right now we currently have n minus 3.5 equals negative 4/5. I want it to just be n equals. So what I need to get rid of is this minus 3.5. So what could I do? Well, in this case, I want to create a 0. So I am going to have to use the additive inverse. So here, what is the opposite of subtracting 3.5? I would say to add 3.5. Whoops, that's not 3.5. So here we're going to add 3.5. Let's check. Is a negative 3.5 plus 3.5 0? Yes, and that's exactly what I wanted. Because why? What's n minus 0? N plus 0. It's just n. So whatever I do to one side to keep it balanced, I will also do to the other side. I'm going to add 3.5. So here, because I made the number 0, I was utilizing the additive inverse property. And again, that goal was to just make 0, because n plus or minus 0 is just leaves me with n, which is what I want. Now here I have a negative 4/5 plus 3.5. So I'm going to go ahead and work that out, because I can't do that in my head. So negative 4.5 plus, I'm going to go ahead and change this to an improper fraction right now. 2 times 3 is 6 plus 1 is 7, so we have 7/2. 10 is going to be our lowest common denominator. We're going to say 5 times 2, it's going to make a 10, so that's going to be negative 8. Plus 2 times 5 is going to give me a 10, that's going to be 35. So here, there are more positives. How many more positives are there than negatives? Well, let's do some extra side work and figure that out. This is going to be 15, it's going to be a 2, so we're left with 27/10. It is positive. Why? Because there are more positives than there are negatives. And this is already reduced. So I'm going to go ahead and say my answer is n equals 27/10. So before we claim this is our final answer, it's important that we also check our work. So let's do that. To check our work, the very first thing we're going to do is replace n with just parentheses. This kind of gives us a placeholder to put in our value in a moment. I'm going to go ahead and do minus 3.5 equals negative 4/5. Now that I have my placeholder, I can go ahead and plug in my value in for n, which was a 27/10. So here we have 27/10 minus, we're going to turn this to an improper fraction, which is 7/2. Let's check to see if it equals negative 4/5. Here we want 10 to be our lowest common denominator, so this 27 is not going to have to change. Bring down that minus. We're going to change a 2 to a 10 by multiplying it by 5, so we're going to minus a 35. Let's check to see if that equals negative 4/5. Well, let's see. If we add the opposite, we can see there's more negatives. How many more negatives are there than positives? Well, let's see. We're going to do 35 minus 27. That's going to be a 8. It's going to become a 0, so it's just 8. So we're going to be left with negative 8/10 equals negative 4/5. Is this true? The answer is yes. And how is it true? If you reduce negative 8/10 by a 2, both in the numerator and denominator, you would end up with a negative 4/5. So I can confidently say that the solution is 27/10. Okay, so I will warn you right now, checking your work is going to feel very tedious at first and very time consuming, but with this, you are going to be guaranteed that the answer is correct, and most importantly, you're going to get more practice with fractions, which with more practice, you will only get better. Okay, so let's try number 2. For number 2, we have w plus a negative 4 and 32 hundredths equals negative 9 and 1/10. So remember, our goal is to get the variable isolated. And in the end, we get something that says w equals blank. So here's the issue. W is on the left-hand side, and it's not yet isolated. We have w plus a negative 4 and 32 hundredths. So what we're going to have to utilize once again is the additive inverse property. Why? Because we want to create 0. Because w plus a 0 is not going to change it at all. It's going to remain a w. So in order to get a 0, we're going to use the additive inverse, which basically means we're going to do the opposite of a negative 4 and 32 hundredths, which is a positive 4 and 32 hundredths, or you can think of it as instead of adding a negative 4 and 32 hundredths, we are adding a positive. So if I add 4 and 32 hundredths to both sides, what's going to happen? Well, if you think of it, a negative 4 and 32 hundredths plus a 4 and 32 hundredths is going to be 0. And what is w plus 0? It's just w. That's exactly what I wanted. I wanted w to be isolated so I can get an answer that says w equals blank. So we're almost there. Here we're going to have to be careful. Are there more negatives? Are there more positives? I'm definitely going to say there's more negatives. So here what we're going to do is go ahead and let's see, how many more negatives are there? We're going to say 9 and 1/10 negatives and 4 and 32 hundredths. Notice I lined up my decimals because we need to always make sure we're combining like things. So here the whole numbers are lined up, the tenths are lined up, the hundredths are lined up, etc. So to find out how many more negatives there are, we're going to finally just find the difference. This is going to become a 10. This is going to become a 0. 10 minus 2 is 8. I can't do 0 minus 3, so I'm going to have to borrow. 8 minus 3 is 7. 8 minus 4 is 4, so I'm left with a negative 4 and 78 hundredths. But again, as always, before we claim that this is our final answer, we're going to have to check our work. So here, to check my work, I'm going to go ahead and replace w with a set of parentheses as a placeholder for my answer, plus a negative 4 and 32 hundredths equals a negative 9 and 1/10. So I'm now going to go ahead and plug in my value for w, which was a negative 4 and 78 hundredths. Here, I'm definitely going to say there's more negatives than there are positives, so my answer is negative. I'm going to have to go ahead and combine to see how many negatives there are. So off of my side work, we have 4 and 78 hundredths. I'm lining that up with 4 and 32 hundredths to make sure the decimals line up. That's going to be 10, carry the 1. That's going to be 11, carry the 1. We have 9, make sure you bring down that decimal. I have a negative 9 and 10 hundredths. Now, is that the same thing as 9 and 1/10? Yes, this is 0. You could have left it out, and you can clearly see they're exactly the same. So I'm very confident that the solution is a negative 4 and 78 hundredths. Okay, so now moving to the next example. Here, for number 3, what I'd like you to do is go ahead and pause the video and try this one by yourself. Okay, so for number 3, we have negative 5 and 4/5 equals negative 2/3 plus c. Our goal is to isolate c. So what is keeping c from being isolated? This negative 2/3. So once again, in this case, we are going to use the additive inverse because we want to make a 0. How do we make 0? Well, if we have a negative 2/3, the only way to make a 0 is to add 2/3. So if I add 2/3 to both sides, negative 2/3 plus 2/3 will create 0. That's perfect because what's 0 plus c? It's just 0. Now here, I'm just going to go ahead and work this out. It's going to be a negative 5 and 4/5 plus 2/3. I am going to want to turn this into an improper fraction. So 5 times 5 is 25 plus 4 is 29. So we have negative 29/5 plus 2/3. 15 is going to be my lowest common denominator. I'm going to have to multiply 5 by 3, 29 by 3 as well. So let's work that out. It's going to be 27. That's going to be 6 plus 2 is 8. So we have negative 87. That is a very common mistake still that some students are doing. They forget to put the negative, so be mindful of that. We're going to multiply this by 5 to make the denominator 15, leaving us with 10. So here we're left with more negatives. How many more negatives? 77. So my answer is negative 77/15. But as always, before we claim that this is the final solution, it is important that we check our work. So here we go. I'm going to first write the equation exactly the way that it looks, but I am going to replace the variable c with a set of parentheses. Now that I've done that, I'm going to go ahead and plug in my value of c, which was a negative 77/15. Okay, with that, I'm just going to go ahead and simplify to see if they do leave with a true statement. So we're going to turn this into an improper fraction, which is going to be a negative 29/5 equals negative 2/3 plus a negative 77/15. Here we're going to keep it as a negative 29/5. We're going to go ahead and create common denominators of 15. 3 is going to have to be multiplied by 5, so we're going to be left with negative 10 plus a negative 77. Since it's already 15, that is going to leave me with a negative 29/5 equals a negative 87/15. Now, are those equivalent? Does that really mean the same thing? Well, I'm going to have to reduce this by 3 to see if it really does equal this. So let's see, 87 divided by 3 is going to go in 2 times. And that's going to go in 9 times. So that's going to leave me with a 29 over 15 divided by 3 is going to give me 5. So is this equivalent? The answer is yes. So I'm very confident that the solution to this equation is indeed a negative 77/15. Okay, now once again, go ahead and pause the video and try number 4 by yourself. Okay, so for number 4, it says 7 and 54/100 plus y equals negative 16. Again, your goal is to isolate y. So how do we do that? Well, note that the one thing keeping y from being isolated is this 7 and 54/100. But now it's a matter of, okay, what do I do to get rid of it? Well, since it's being added to y, the only thing I can think of is to make it a 0. And the only way to do that is by using additive inverse. So the additive inverse of 7 and 54/100 is a negative 7 and 54/100. So that's going to leave me with a 0, because what is 7 and 54/100 minus 7 and 54/100? 0. So that's going to leave me with y equals a negative. So here, since they're both negative, let's figure out how many negatives we have all together. Make sure you understand that a whole number decimal belongs at the end. Let's see how much we have. We're left with 23 and 54/100. Before we can claim that this is our final answer, let's go ahead and check our work as always. We're going to go ahead and write 7 and 54/100 plus a value for y is going to equal negative 16. I can go ahead and plug this value in now for y and check to see what I have. There's definitely more negatives, so that's going to stay negative. There are 23 and 54/100 negatives and 7 and 54/100 positive, so let's find the difference between these two. That is going to leave me with 16. Now, is that the same thing as negative 16? The answer is yes. So I'm very confident that the solution is y equals negative 23 and 54/100. Okay, so now changing it up a bit. This is one that often gets students a little confused. For number 5, I would read this out loud so that I can determine what is happening with the variable. So I would read this as negative 3 and 84/100 equals 2 and 4/10 times m. Now, why did I say times m? By doing that, I'm understanding the operation that's occurring between these two values. Since I am trying to isolate m, I do need to get rid of this 2 and 4/10. And since they're being multiplied to one another, I don't want to make it into a 0. Why? Because if I make it into a 0, 0 times m is 0. I would essentially be eliminating the variable instead of isolating it. So this is the case where I do want to create 1 instead of 0. So in this case, to get rid of that, I'm going to do the inverse of multiplication, which is division. So I'm going to divide both sides by 2 and 4/10. So that's going to go away, which by that I mean it's going to turn into 1. 2.4 divided by 2.4 is 1. What is 1 times m? It's just m. Here, our answer is going to be negative because the negative divided by positive is a negative. Now I'm going to go ahead and divide this out. 3 and 84/100 divided by 2 and 4/10. Our decimal moves over one place. 24 can't go into 3. It can go into 38 once. With a remainder of 14, let's bring down that 4. I'm going to go ahead and say that 24 goes into 144. Let's see, about how many times? Maybe 6 times? Yes, it does go in perfectly 6 times. So I'm going to go ahead and say my answer is negative 1 6/10. Now, before I move on and say that this is my final answer, I need to once again check my work. So let's write negative 3 and 84/100 equals 2 and 4/10 times a value for m. I am claiming that the value of m is a negative 1 16. So let's check this out. A negative 3 and 84/100 equals a negative. So in this case, we're going to have to multiply to see if it does work out. 24, carry the 2, that's a 6. 12, carry the 1, that's going to be a 3. And I have to move my decimal over one place value. Whoops, I didn't catch this one right here. That's decimal as well. So there's 2, 1, 2. It's going to leave you with negative 3 and 84/100. So guess what? This checks out, so I can confidently say that the solution is negative 1 6/10. Okay, so for number 6. Number 6, almost the same idea, but now we're working with fractions. So what's going to happen here? Well, first, it's important that you know how to read it and understand what's happening with the variable. This is 4/5 times x equals negative 3 and 3.5. I am going to try to isolate x, so in order to do that, I'm going to do the inverse, and I'm going to do that to create a value of 1, because what is 1 times x? It's still just x. Now, if I turned it into a 0, what's 0 times x? It's 0. I do not want that. So in this case, we have 4/5 times x, so the inverse, aka the opposite of multiplying by 4/5, would be to divide both sides by 4/5. I'm going to go ahead and divide by 4/5. So what is 4/5 divided by 4/5? Well, for anything divided by itself is just 1. So 1 times x is x. Now here I am going to say this is a negative 3.5 divided by 4/5. This is what we call a complex fraction. It does look a little strange, but basically we're just dividing these two fractions. A negative divided by positive is a negative, so I'm going to put that right away. Let's do some side work. Negative 3.5 divided by 4/5. I'm going to change that to, first of all, let's remember we already took care of the sign, so I really don't need this anymore. We're going to have 7/2 divided by 4/5, which can be changed to 7/2 times the reciprocal. I can't cross reduce, so I'm going to be left with 35/8, negative 35/8. As always, before I can claim that this is my final answer, let's check our work. We have 4/5 times a value for x equals negative 3.1/2. So in this blank, I'm going to go ahead and put in my value of negative 35/8. This is going to be negative. I am going to go ahead and cross cancel right here because I can by 5. It's going to create a 7, and then between these two numbers we can reduce by 4. So that is going to leave me with negative 7.5 equals negative 3.5. Now, are these the same? Well, let's think. 2 times 3 is 6 plus 1 is 7. Is negative 7 halves the same thing as negative 7 halves? The answer is yes, so I can confidently say that the solution is x equals negative 35/8. Okay, so last one on my end. For number 7 here, we have negative 5/9 equals d divided by 1 and 1/2. Once again, our goal is to get d by itself. And the way to do that is to create a 1. So we are going to be utilizing the multiplicative inverse in this case. Why are we choosing 1? Because anything times 1 isn't going to change the value of it. So real quick, I am going to reread this one more time so we can figure out what the inverse operation is going to be. We have d divided by 1 and 1/2. What is the inverse of dividing by 1 and 1/2? Well, the inverse would be to multiply by 1 and 1/2. So I'm going to go ahead and do that to both sides. Here, a negative times a positive is a negative. I'm going to go ahead and do 5/9 times 1 and 1/2, which is the same as 5/9 times 3/2. I can cross reduce by 3 here. And I can't cross reduce here, so my answer is 5/6. In fact, it's a negative 5/6 equals. Notice 1 and 1/2 and 1 and 1/2, you can kind of imagine them cross-canceling one another, leaving with just d over 1, which is d. So before I claim that this is my final answer, hopefully you remember we need to check our work. So let's do that. We're going to go ahead and use a negative 5/9 equals a set for d over 1 and 1/2. Here I'm going to go ahead and replace the value of d with the value of negative 5/6. So on the left-hand side, we have negative 5/9 equal. Now over here, I'm going to have to work that out. We have a negative divided by a positive is a negative. So far, so good. We have 5/6 divided by 1 and 1/2. Now here's where a lot of students tend to mess up because they want to try to do too much in their head, and that will often create some mistakes. So here, take your time, show every single step. We're going to go ahead and keep the first fraction. We're going to change it to multiplication and take the reciprocal. But wait, can I really take the reciprocal of 1 and 1/2 just yet? No, I need to turn it into an improper fraction, which is going to be 3/2. So I'm just going to go ahead and multiply by the reciprocal of 3/2, which is 2/3. I'm going to cross reduce by 2 here, leaving me with a negative 5/9. So are these the same? The answer is yes. So I can confidently say that the answer is negative 5/6 equals d. Okay, so with that said, now it's your turn. You go ahead and pause the video and try numbers 8 through 11 all by yourself. Let's go ahead and go over the answers. For the next 4 problems, I am just going to give you the answers and show you quickly the steps that would have given you the correct answer. Now, I won't be checking the work only because this video is going to be very long if I do. Now, should you be checking the work? Absolutely. But again, to keep this video at a minimum, I'm going to go ahead and just give you the answer. So for number 8, what you would have to do to isolate our variable would be to, in this case, since it's negative 4.5 plus g, we're going to do the inverse of a negative 4.5, which is plus 4.5 to both sides. Now, if you do that to both sides, this is going to create a 0, leaving us with g equals 23/18. Now for number 9, this is negative 5 equals c divided by 5/16. Since we are trying to isolate c, I'm going to do the inverse of dividing by 5/16. What's the inverse of dividing by 5/16? Well, it's to multiply by 5/16. Now by doing that, you can see that I can cross cancel. It does create a 1. C over 1 is just c, so that's exactly what I wanted. I'm going to go ahead and multiply this side by 5/16 as well, which is going to leave me with negative 25/16 equals c. For number 10, this is negative 4.5 times g. So the inverse of multiplying by the negative 4.5 would be to do the inverse, which is divide by negative 4.5 to both sides. Real quick, you can see that the negatives cancel each other out here, leaving me, also this cancels out because negative 4.5 divided by negative 4.5 is just 1. 1 times g is g. if you divide these two fractions, and the order does matter because division does not have a commutative property, you should end up with 58 over 81. For the last one, we're going to try to isolate y. So in order to do that, I do need to get rid of this minus 321 thousandths. So since it's minus, I'm going to do the inverse, which is to add 321 thousandths to both sides. That is going to leave me with y equals, obviously there's more negatives. How many more negatives are there? There's 5 and 289 thousandths more negatives. So that is the answer for all four problems. Please make sure you have the correct answer. If not, feel free to go back into the previous examples and see how those were done to see if you can figure out what your mistake was for these four problems. We're almost there. Okay, we just have two more. It says, solve the equations below with your shoulder partner, show all your steps. If you're watching this video, you don't have a shoulder partner necessarily, so you're going to be going ahead and trying the problem and then checking the work with my video here. So go ahead, pause the video, and let's see how well you do. Okay, so let's check our answers. Well, here we're trying to isolate W, so I need to get rid of this 3. Well, what is happening with the 3 and the W? Technically, this is 3 times W. If you want, you can kind of squeeze in a multiplication sign in there. So in order to get rid of the 3, I'm going to have to divide both sides by 3. 3 divided by 3 is 1. 1 times W is just W, which is what I wanted. And 0 divided by 3 is 0. So the solution is W equals 0. Now, here I can quickly check to see if this is true. 3 times parentheses for W equals 0. I'm going to go ahead and plug in my value of 0. Is this true? 3 times 0 is 0. Does 0 equal 0? Yes. So I know my answer is correct. Now let's take a look at this one. This one's 0W equals 3. So what do I do here? Well, again, we're isolating W. So what does this mean? It means 0 times W. So the inverse of that would be to divide both sides by 0. So here, these are going to cancel out and leave us, well, kind of, okay? And we don't have to get into the logistics of that, but just know that this would leave us with a W equals, and let's see, is this really a 0? Let's assume we thought it was 0 for a second. We did already talk about things like this, but let's go ahead and pretend we thought it was 0. Okay, if I were to check my work, I would have 0 times a value for W equals 3. And I would plug in this 0 and say, hey, 0 times 0 is 0. Does 0 equal 3? No. So this tells us it cannot be 0. In fact, if you remember, this one would actually be no solution. Why though? Because you can't divide by 0. In fact, here is the proof. Because 0 times 0 does not equal 3. The same way we would say, hey, let's see, 24 divided by 4 is 6. And I know this because 6 times 4 is 24. Now, if we do the same thing with 3 over 0, if we claim it's 0, we're trying to say that 0 times 0 equals 3, and that is not true. So here the solution is, there is no solution. Okay? But you're going to learn later in 8th grade that this is called undefined, but we're not going to talk too much about it in 7th grade, but just keep that in mind so when that does roll around, you're going to be like, oh yeah, I remember that. Okay, so that actually concludes the lesson for today. Thank you so much for tuning in. And before I leave you, just a friendly reminder, please hang in there with checking the work. Again, it's going to seem like a long process. It's going to seem tedious. It might not feel worth it. But in the end, it will be, because now you're going to know whether or not your answer is correct. And most importantly, you're going to get extra practice, which means you're going to get better at fractions and decimals. So hang in there. Again, thank you so much for tuning in. And until next time, bye.